This is our FPGA assignment demonstration. I'm Ishan Wickremasinghe. My student number is 246388013.
I'm Ashwen Kugan. My student number is 245564449.
So we begin the compilation. So this is the initial stage. Now we're gonna enter our code, which is 1100. So now we have it in the log mode trying incorrect passcodes. So it doesn't go to the clock mode. I'll type press 1101. Our correct password is 1100.
This is our overview of our schematic. First off, we have the debouncer, which eliminates multiple readings in a short span called bounces. This is done by an input signal into multiple flip-flops to filter the noise and produce a clean signal.
Then we have the sequence recognizer, which receives the button inputs 0 and 1, where it checks whether the user pressed the correct sequence in even odd format, which is for ours is going to be 1100. If the correct sequence is entered, it will display the decimals that have been pressed and goes to clock mode. Otherwise, it will stay at lock mode, and the SSD will display 4 E's.
Next, we have the pattern display, which receives an input signals from the sequence recognizer and outputs it as we enter the passcode. If the sequence recognizer does recognize that it is the correct sequence, it's going to pass the signal to the hex 2 SSD via the 16-to-1 MUX and the quad 4-to-1.
Below that is the 4-bit BCD counter, which consists of 4 individual BCD counters connected to work synchronously to make the counter count, which it also connects to the hex 2 SSD via the 16-to-1 multiplexer and the quad 4-to-1 multiplexer to display the decimal count in 10-second, 1 second, a 10-second, and 100-second intervals, and stops at the student number 8013. Then we have the 16-to-1 multiplexer. This consists of 16 individual 2-to-1 multiplexers in order to differentiate inputs from the pattern display and the 4-digit BCD counter, and thus the output be either the pattern display from the clock, the lock mode, or the counter from the clock mode. Note that we use this 16-to-1 multiplexer instead of the 16-to-4 multiplexer and the 8-to-4 multiplexer, because the 16-to-1 multiplexer is much more simpler in complexity and provides the same reduced delay when sending and receiving signals. However, the 16-to-1 provided limited flexibility to select the desired output, but for this circuit, this was effective enough.
Next, the 16-to-1 MUX is connected to the quad 4-to-1 MUX. The purpose of this is to take the inputs and selects the relevant data source to be activated and displayed in the hex 2 SSD. 2-to-4 decoder takes 2 inputs and turns them into 4 outputs with the combination of 4 AND gates and NOT gates. This conversion allows each valid input word produce a unique output. A hex 2 SSD is constructed from truth table by the A to G segments, allowing which segment should be turned on or off, with inputs W, X, Y, Z, inputs to output relevant segments to create the desired pattern or sequence on a 7-segment display.
Done.
Thank you for joining us. Please subscribe. Please go to Twitch. Yeah, I think I stuffed up on some stuff.